Green means go, right? Hopefully this is working. I've made some tweaks to my OBS configuration, so hopefully the stream will be a little bit more smooth. I'm using the hardware encoder on my Mac here, and for whatever reason, it does not like the transitions from kind of like the solid colored backgrounds from the slides and then to the actual video. So it worked in tests. We'll see if it works in reality when I'm actually streaming. Let's get this going. Make sure I got audio. OBS configuration, so hopefully the stream will be a little bit more smooth. We got audio. Let's do this. Thanks for being here today. Today we're going to be talking about app logging and log backends. So we're not going to go too crazy deep into logging, but we will kind of touch the surface of all of the important things about logging. So here we go. And if you haven't already subscribed, please do. But more importantly, leave a comment below if you have things that you want me to cover on future live sessions. Try to do these every week, and almost everything now is submitted from the community. So especially today was one of our awesome community members that always writes in with good questions. So really appreciate it. So without further ado, let's do this. So this is from Shannon, and what he said is, when you call log_error, where does this go, or can I redirect these to a certain place? And we'll talk about that shortly. So Zephyr's logging API is extremely flexible, and it allows you to not only kind of just like send logs to a UART output, but you can redirect those logs to different places, or you can have them running simultaneously at the same time. You have the options for UART, RTT, which is anything that's ARM based. You have the ability to kind of push things over RTT, and specifically JLink. I think RTT is a JLink. I don't know, proprietary communication protocol, but it's essentially over the same interface as programmers for ARM chips. Yeah, you have USB, so we've kind of touched on that in the past, where you can kind of send console logs over USB once it's plugged in. And there's also an option for you to create your own backend. So the idea here is, there are some examples in Zephyr, but you can send things over the internet. So they have these network-based logging backends, which are very handy. But you also have the option to save to the file system. For instance, maybe you have an SD card that you like to save logs to, and that is a perfect opportunity to use those backends to save those logs. I know for at least some of my customers, clients, that's a requirement for their devices, just so they can understand if there are any kind of failures in the field. They have an idea, and they aren't able to get any data from the devices at the time. They can at least get the device back, take out the SD card, plug into a computer, and be like, all right, what happened? Why did this stop working at this specific time? And hopefully those logs will kind of provide some more insight as to why that might have happened. So we'll touch on some of the, before we get into like the different methods of the backends and switching to UART or RTT or whatever, I do want to touch on like the three main modes of logging, because they are important for your application and just good to know in general. For Zephyr, anything within recently and within the past couple SDK iterations, they've been working on a new logging subsystem called, and it was called Log2. That is now the default for anything above Zephyr 3.0, so that's something just to bear in mind. If you've ever used the logging infrastructure, especially related to copying strings, you are very familiar, painfully familiar with the log_stir dup, which is the string duplication method, which basically puts the string on the heap until it has been pushed to the logger output. That is no longer necessary. It's kind of built into the logging subsystem, so you don't have to do that anymore. There are some funny things you have to do with just making sure that when you're defining those strings that you're wrapping or casting them to a specific pointer type, that way the logging subsystem macros and all the compilation magic that happens in the background knows how to handle that particular item. We're not going to go into details about log2, but at the end there's like I wrote like a couple of different examples, and you'll see one that I actually casted to a char pointer, so something to keep in mind. But the different log modes and the different let's go back to log modes. The different log modes, you have the options of using a deferred mode, but deferred mode essentially uses a background thread to process the log. So you might be calling log_inf, but it's only processed later on when the processor has, or the current task has kind of released, and it can run these background tasks. So the log thread is a lower priority thread that just runs the logging stuff. But in some cases, that is not great. If you're doing something maybe a little bit more real time, if you want to see something print out maybe before your device croaks, you can set it. You can use the immediate mode. So immediate mode kind of does not use the deferred thread. It prints right out. But for performance reasons, it's important that if you have a real-time application, maybe you don't want logs being printed out because that will slow down anything that's real-time. If you have logs in an important loop within your program, especially if it's a tight loop or something like that, you definitely do not want to be using immediate mode, but it's handy in some cases, especially for debugging. And then you have I didn't even write it, I just refer to what it does. But the minimal mode, so minimal mode removes extra timestamps, colors. Essentially it just removes as much functionality from the logger as possible without losing the logger functionality itself. This is great for if you have a space constrained project and you want to have logging, but you don't necessarily care about all the crazy timestamp prefixes and colors and all the extra farkles, all the things that come along with the logger by default. But all that stuff takes up space. So here they are in the K configs, just what they're defined as, and you can see buffered and processed later for the deferred. Immediate, this is processed in the context of the call, so that's important, and it will have performance impacts. And then the minimal, which is the last one I didn't get there, but basically it's just a tiny wrapper on top of the print K implementation. If you're just looking to do something basic without even connecting anything to the logger infrastructure, print K is just another option that you can do. That's literally that's kind of like similar to a C call on your computer where you can just do printf. It's very similar. Print K, print K for kernel, but it's all up to you and how you'd like to use it. But if you'd like to use the logging infrastructure, then that is an option as well. So what we're going to do now is we're going to jump into the kind of different modes that you can use the logging back, or the log in general. You can use it for UART. So we're talking about the mechanisms for transmitting logs. So we'll start with UART, and then we'll just go through the list. I'm going to show the different configurations and maybe some overlays just to show the differences in how to set it up. And then at the end, we'll show some log API calls that should be very familiar if anybody's been working with Zephyr for a while. And we'll go from there. So by default, most likely, you don't even have to do anything to get your logging working because it's a general sane default for most boards in Zephyr. So, but for some reason, if you don't have it, then you can set serial to yes, console to yes, UART console. UART console is probably the most important thing here because that says, hey, I want to set the console to the UART, and the console is where the logs get printed to. And of course, enabling logs. So we're just turning everything on and making sure it is ready for printing out to UART. And in some cases, the overlay tweaks are required, and I'll show you here. So this is like a sane default, which is using UART 0 as a console, show UART, UART, MCU Manager, things like that. So most likely this is going to be default the way it is here. You don't have to change it if you want to use UART 0. Now, if you are maybe using UART 0 for another part of your system and you need to use another UART interface, you can remap using an overlay to switch to that interface. I've done this many times just to switch to a different interface for whatever reason. If the application by default, it just really depends on your application, but it's cool because you can map that interface to whatever you want. And I'll show you in a bit, and I've talked about this before in the past. You can actually set, for instance, the USB interface and replace that here. Instead of having UART 0, you have the USB interface. So I'll show you that in a second. Here's the RTT logging. And the only thing different really you have to do here is enable RTT, and then also set the RTT console equals yes. And you can turn off the UART console if you're not using it, especially if your interface isn't defined or maybe turned off. In theory, you should be able to run both at the same time if they're both enabled. I've seen that in the past where I've run devices where I've looked at the UART console and also the RTT console, and they're both spitting out logs at the same time. So that is also an option for you. RTT comes in clutch because it's very handy to use if you're running out of pins or if you ran out of UART interfaces and you need some way to get some log data off your device. That's what I mostly use it for. It's not my go-to. It's much easier to hook up. Like right now I have a Thingy 91 laying on my desk, and I have two USB to UART devices plugged into it for different interfaces for the two processors on there to log output from there. And it's just much easier to deal with that rather than connecting RTT, setting up a console, setting up a RTT daemon, and all that other fun stuff. But if it's the only thing you have, then that's the best. That's the best option. You do have to have a programmer. You do have to have the appropriate cable to connect to your device, and that has to be connected the whole time for it to work. RTT in general will also consume a lot more current. So if you're running off a battery, you might have to figure out another option. I've noticed on like an NR52, or on either one, NR52, NR91, you can go from microamps to milliamps when it's running the RTT console. So that's another caveat that I didn't include in the slides, but it's just something to keep in mind if you're going to be using RTT. USB logging, biggest thing here is just turning it on, turning on the device stack, and one thing I didn't do here, the UART console should be set to yes, not no. So that's important if you wanted to send any logs over UART. And then additionally, like I mentioned before, just shortly before, if you want to set the output of the console to a different interface, you just have to remap it. So we set it up here below, and we're setting up the CDC UART interface. And then we're mapping it in the chosen portion of the overlay. So now here's the fun stuff, and this is something I've played with in the past. And actually, I did include some links in the description below to some other great resources, especially related to a net backend for logging. So they do have a very basic example in Zephyr where you can push logs over UDP. It's not encrypted, it's not anything, so keep that in mind. But the cool thing is you can just send logs over the internet. Maybe you don't have access to that device, so it's a great option. There's also a link to Goliath's log backend, which are using what is it? they're using UDP, so they're using CoAP, and they're sending that encrypted to their backend service, and they're sending the logs that way. So you can kind of take a look at how they implemented their log backend. It's a little bit more complicated, but you have get an idea of like how you could potentially use this, or how you can create your own log backend if you want to, especially related to if you want to send things over the network. One thing I did leave out that I didn't have enough time to play with, and I know that was one of Shannon's requests, was file system. There is some file system stuff in there. If you go to that syslog net sample, I think there are a couple other samples within the general area of Zephyr that are also logging. You can log to the file system. I believe they're there. So that's just another option. We'll jump back into here though. The most important thing here, besides turning on the log backend, is making sure you're actually connected to the internet somehow, making sure that you have networking enabled. So this will work across different devices if you have, say, NRF91, which is LTE, or if you have a device that's connected over Ethernet or whatever. The important thing is to establish that network connection, and then you can send the logs over that network connection. Depending on your connectivity, maybe you have an NRF91 that maybe just sleeps most of the time, it's not connected, then you probably have to figure out your log backend where you actually cache some of those logs to a file system before you actually send it out when you're actually connected. So here I'm just setting I'm using the backend underscore net, so that's like the default network logging backend, and that's the one that actually connects over just plain old UDP, no encryption, no anything. And this is a super basic server that I wrote. I didn't even write it. It was actually a sample from somewhere else that I grabbed just to retrieve the logs from the device, and it was just for kind of a debugging session I was doing. And it works. It just receives the logs, and whether or not they get there, because it is UDP, it's okay, but most of the time it works pretty well. So it was kind of cool to see that, that I was just sending the logs. I was looking at them locally, but I was also seeing them on my machine, whereas I can disconnect and also continue looking at them as I was debugging the device. And of course, no talk about logging is complete without actually showing kind of the main logging API commands. So you can use these guys as if you were doing kind of a printf or printk, whereas you can actually insert parameters in there, and the macro will actually kind of automatically concatenate, put everything together. It's very handy. You can see that I used that, I casted that log buff to a pointer, and that will basically tell the log to subsystem to make sure that that is saved in the heap somewhere until it's processed. And that's especially important for the deferred log version or mode. And this is all done magically. You don't have to worry about allocating any log buffers anymore or worrying about any of that. It's all done within the kernel, which is fantastic. And of course, like I mentioned, this is all available in the newer versions of Zephyr. If you're using something like NCS 1.7 or above, maybe a little bit older, you can actually use the log2 subsystem, but obviously it's not the most up-to-date one compared to what's being used in Zephyr 3.0. So it is an option. I actually switched over to using log2 in a NCS 1.9.1 application. So it's kind of it's up to you. You might run into bugs considering that's whatever 6 months ago. But if you're using the newest version of vanilla Zephyr, you should be able to use log2 no problem. So this was a very quick and dirty introduction to logging backends. There's a lot here. I could probably talk for an hour or two about it, but you have some really flexible backends. You can have Zephyr makes it really flexible to kind of route your logging to wherever you want it to go, which is cool. You have the logging modes, which make it easier to maybe make it easier in your application size if you need to see things immediately for debugging, Or if you don't really care and you just want to use the default deferred mode, that's all up to you. You have the the different logging levels that you can use for your application. So one thing I did not talk about is the log levels. So you have info, you have debug, you have error, you have warning. All those have different levels and they can be turned on or turned off depending on your application. So say you have a lot of debug output and you want to squelch that for your production versions, that can get turned off during kind of a production build, which is very handy because it'll not only squelch all that, it'll remove it, but your code size will also decrease because you're not storing all those strings inside your application itself. So that's kind of pretty standard for any type of logging infrastructure, is to have those different levels. They might have different names, but essentially it's the same concept. And the idea here is you can kind of remove things that maybe aren't as critical, often for production devices, production setups, and for backends or embedded devices. The warnings and errors are left on, especially if they're being saved somewhere, because then you can see the errors as they happen, or you can look back and compare timestamps and be like, oh, okay, there's an error here, like what does it look like on the back end, or so on and so forth. So it's very handy for debugging in the field if you need to, but it just gives you flexibility. That is for sure. And that's it. Make sure that you jump over to jaredwolf.com, subscribe to my mailing list. I send an email out. Also, there's been some interest in some courses, so I'll probably be making an announcement there. So make sure that you are on the mailing list because you will be first to know. So let me see if there are any questions. Questions. The view so far, the video is great. That's great. I'm glad it's working better because I know it's kind of painful for everyone. It was painful for me to watch it. I was like, ugh, this is terrible. So glad it's working better. It's been a learning experience because I switched to actually using a different camera. So, but I'm glad it's working. But if maybe you're watching this video later, you have questions, feel free to leave them in the comments below, and I'll try to focus on them for my next live session. And I really appreciate you being here, watching the video, giving feedback. That's what makes these live sessions happen. So thanks again for being here, and we'll see you in the next one.